KZN Grade 10, November 2023, Paper 2. Question 3. In the diagram below, we're given these coordinates A, B, C, with just X and Y, and D, which are the vertices of this quadrilateral ABCD. Okay, and then we have some questions. So first we're asked to calculate the gradient of AD. So we want the gradient of this line here, and we know that the gradient is equal to rise over run, which is the change in the y value over the change in the x value. So MAD is equal to the change in y over the change in x, which means I'm taking the y value of A minus the y value of D divided by the x value of A minus the x value of D, and I was given these two coordinates, so the y value of A is 4 minus the y value of D, which is 0, and the x value of A is also 4 minus the x value of D, which is negative 6. Now 4 minus 0 is 4, and 4 minus 6 is 4 plus 6, so this is 10. And I can simplify this. I can divide the numerator and the denominator by 2. So I have that the gradient is 2 over 5. In the next question, determine the equation of the line BC, which is parallel to AD. So I want the equation of this line BC, and I'm told that it's parallel to AD. So straight away I know that if these two are parallel, they have the same gradient, so m of BC is going to be equal to m of AD, which we just found to be 2.5. And then I'm just going to use my equation of a line, which is y equals mx plus c. I have a y value, I'm going to use the b, because I just need one coordinate that lies on the line to be able to get the equation of the line. I need one coordinate and I need the gradient. So for y, I'm going to put in y minus y1. I'm going to put in this y value for b, which is negative 1. And then it's equal to m. I found that the m was 2 over 5 because it's parallel to this line AD. And then that's m times x minus x1. And the x I'm going to use is the x of b, which is 2. So the first thing I'm going to say is that MBC is equal to MAD, which is 2 over 5, and that's because they parallel, I was told. Then the equation of a line, I can use this equation. Okay, and then I'm going to substitute these two for the coordinates of one point that I know lies on the line, which is B. And then I'm going to substitute this m for the m that I found earlier. So for these two, I'm going to use the coordinates of B. Okay, so I substitute everything in. I have y minus the y coordinate of B, which is minus 1, is equal to m, which is 2 over 5. And x minus the x coordinate of b, which is 2. Okay, this is y plus 1, and this is 2 over 5 times x, and then 2 over 5 times minus 2 is minus 4 over 5. And then my equation of the line, I want it in the form y equals mx plus c. So I've already got a y on this side, I'm going to leave that there, and then I've got my m, which is this, and x on the right-hand side, which is what I want, and then all I need is the plus c, so I just want one number that's going to be in my equation, which means that I have this negative 4 over 5, that's fine, but I want this 1 to come over here and join this number, so the positive 1 is going to become a negative 1 on the side, and it's not going to be here anymore. And I know that minus 4 over 5 minus 1 is minus 9 over 5. So my equation of the line is y equals m is 2 over 5 x minus 9 over 5. Right, then I'm asked to determine the coordinates of E, which is the midpoint of the line BD. So go back to my diagram. So this is BD and then this is E. And I want to find, and I'm told that E is the midpoint, so I can just use the midpoint formula for these two coordinates to find the coordinates of E. So I'm going to say that X and Y of E equals midpoint BD and that's equal to the for the first bit, the x coordinate of E is going to be the x coordinates of each of these points added together, divide by 2 to get the halfway, and then with the y I do the same thing, y of B plus y of D divided by 2 to get the halfway. Okay, so x of B was 2, and the x of D is minus 6 over 2, and the y of B was minus 1, and the y of D is 0 over 2. Okay, so the x coordinate of E is 2 plus minus 6, which is minus 4, divided by 2 is minus 2. And then the y coordinate of E is minus 1 plus 0, which is minus 1, divided by 2, which is minus a half. Okay, 3.1.4. Now I'm told that the quadrilateral ABCD is a parallelogram, and I'm asked to calculate the coordinates of C. So if this is a parallelogram, that means that these diagonals bisect each other, which means that if E was the midpoint on this one, on this line, if E was the midpoint on this line, then it means that E is also the midpoint on this line, which means that the x of C plus the x of A divided by 2 is equal to the x of E, and then the y of C plus the y of A divided by 2 is equal to the y of E. That's just using the midpoint formula. So I know that E is the midpoint because of the diagonals bisecting in a parallelogram, and so I can just write an expression for the coordinates of C by saying these x's added together divided by 2 is the midpoint x of E, which we've just found, and I do the same for the y values divided by 2 y of E, which we've just found. So E is midpoint of AC. So the x of E is equal to the x of C plus the x of A over 2, and the y of E is equal to the y of C plus the y of A over 2. And now I can put in the values that I know. So my xe was minus 2, x of C is what we're trying to find, and the x of A is 4 over 2. And then y of E we found was minus a half. Y of C is what we're trying to find. Y of A is 4 over 2. Okay, then I solve for x in both cases. Oh no, I solve for x on this one and I solve for y on this one. So for this one, I'm going to have, I'm going to multiply this side by 2 to get rid of this divide by 2, which means this side is also multiplied by 2. So I'm then going to have negative 4 is equal to x of C plus 4. Then I want to take this 4 over to the other side to get x of C on its own. So that positive 4 becomes a negative 4, and I'm going to have that negative 8 is equal to x of C. And then similarly on this side, I'm going to multiply everything by 2. So on this side, I'm going to have minus 1, and that's going to be equal to y of C plus 4. I take the 4 over to the other side, so I can have y of C on its own, and the 4 becomes negative. So I'm going to have minus 1 minus 4 is minus 5, and that's equal to y of C. And then I have my coordinates for C. So -8 and -5, and I go back to my diagram, and this makes sense, right? Because I expected the x and y to be negative, and I expected the y value for C to be a bigger number than the y value for B because it's lower down in the diagram, and I expected the x value for C to be a bigger number than the x value for D because it's more to the left in the diagram. Then 3.2, we're given these points P, Q, R, and S with the x value missing for x, and we're asked to determine the value of x if PQ is perpendicular to RS. So I know that if two lines, PQ and RS, are perpendicular, then that means that the gradient of the one multiplied by the gradient of the other one must equal -1. Alright, so I know all of the values for P and Q, but I don't know all of the values for R and S. Remember this S, the x value of S is missing, which is what we're trying to find out. So I'm first going to find the gradient of P and Q because I have all the information that I need. So again, just using the gradient formula, it's change in y over change in x. So I'm going to have the y of P minus the y of Q over xp minus xq. So y of P is 3, y of Q is 4, over the x of P minus 2, and the x of Q is -1. So I have -1 over -3, which is 1 over 3. So I want a value MRS that when I multiply it with MPQ, it's going to be -1. So I want something that I multiply with 1 over 3, and I get -1. So this I multiply with something, and I get -1. And that is only true when the something is -3. So I know that the gradient of MRS must be -3. Alright, and then I can use the gradient formula to say that so now I know the gradient of MRS, and now I can use the gradient formula in the same way that I did for P and Q. So I'm going to have that the change in y over the change in x, but for R and S now, is going to be equal to -3. So -3 is equal to change in y over change in x. And now the y and the x that I'm using are R and S. So I know the y of R is 1. And I know the y of S, which is 4. And I know the x of R is -4, but I don't know the x of S. So this now is equal to -3, and I can just solve for x. So first I'm going to multiply everything by this denominator. So on the left-hand side, I'm going to have -3 times -4 minus x. And I'm just left with the numerator on the right-hand side, which is 1 minus 4, which is -3. So I can divide everything by -3, and I have this. And then I want x to be on its own, so I have -x. I take -4 over to the other side, and the -4 becomes positive, so I have 1 plus 4, which is 5. And I wanted to solve for x, not for -x. So I divide or multiply everything by -1, and I get that x is equal to -5. KZN Grade 10, November 2023, Paper 2, Question 7. The diagram shows a drinking glass with an inner diameter of 50 millimeters and a height h. Ignore the thickness of the glass. And the volume of the glass is 250 centimeters cubed. Calculate the height h. So first of all, I know that my formula for the volume of a cylinder, like I've got here, is that the volume is equal to pi r squared h. So I know the volume, I was told it's 250. I know pi, it's just a number. Then I need r, which is the radius of the circle, And I was told that the diameter is 50 millimeters, so I know that the radius is 25 millimeters. But the volume I was given in cubic meters, so I need to change this millimeters to centimeters. So R is 2.5 centimeters. So I can substitute that into my equation, so it's 2.5 squared, and then h is what I'm trying to find out. And then I'll just have h is equal to pi of 2.5, sorry, this is 250 divided by this. So it's 250 divided by pi times 2.5 squared, and you can just put that all into your calculator, and you get that h is equal to 12.736 centimeters. Okay, now we have that water is poured into the glass until it's 65% full. Calculate the total surface area covered by the water. So 65% full means that this height of the water is 65% of the total height of the glass that we've just found. So water height (0.65) or 65% times 12.736, and that is 8.034. Then the surface area, we're going to use the new height, 8.034. Then I can just use my formula for the surface area of a cylinder, which is the surface area of the rectangle that makes up the cylinder, which is just pi r squared, plus the surface area of the two circles that make up the cylinder, so this one and this one, which is 2 pi r h. And now I'm going to use the same r that I had before in centimeters, so it's going to be 2.5, and then this h is going to be my new h that I found here. So I'll have pi 2.5 centimeters squared plus 2 times pi times 2.5 times my new height, and I can put that all in my calculator, and I get that the surface area is 70.11 centimeters squared. And this is question 8. So we're told that in the diagram below, BD is parallel to EF. And we're also told that AB is parallel to DE. And BE is equal to EC. And AD is equal to 10. So 8.1.1 asks us to show that FC, which is this one, is equal to 5 centimeters. Okay, so the first thing I notice in this diagram is that I've got a lot of parallel lines going on, and I'm working in triangles, so I think I can use the midpoint formula, and indeed I can see that this line of triangle ABC is parallel to this line DE, and I was told that EC is equal to EB, which means that E is the midpoint of this line. So if E is the midpoint of one side of triangle ABC, and there is a line that joins that midpoint to another line of triangle ABC, which is parallel to the third line of triangle ABC, then by the midpoint formula, D must be the midpoint of this side of triangle ABC. which means that DC would be equal to 10. So I can say that DC equals 10, and that's the midpoint theorem where AB is parallel to DE. So now that I know that DC is equal to 10, and I'm trying to prove that FC is equal to 5, which means that DF equals to 5. So I basically want to prove that F is the midpoint of this line DC. And again, I can see that in this triangle now, this BCD, I've got one side of the triangle, which is parallel to the line that's joining this midpoint to the second line of the triangle, which means that F must also be the midpoint on this line. And if F is this midpoint, then this side of F is 5, and this side of F is 5, because the total length of DF was 10. And this one is BD being parallel to EF. Then 8.1.2, if AB is equal to 16 over 5 times FC, prove that ABC is 90 degrees, so that this angle is 90 degrees. So I know that the value of FC is 5, we've just shown that. So then AB must be 16 over 5 times 5, which is 16. And we know that this one is 6 and this is 6, so the whole length of this side, BC, is 12. Okay, so I now know the length of AB to be 16 and this line to be 12. And now if this triangle has a 90-degree angle here, that means that by Pythag, AD squared should be equal to the sum of these two squared. And I knew that AD is equal to 10 and DC is equal to 10. So this whole line AC is 20. Okay, so I want to see if 20 squared is equal to the square root of 16 squared and 12 squared. And you can check in your calculator, it's true. Therefore, that angle B is 90 degrees. And the reason is the converse Pythagoras theorem. The reason I'm writing converse Pythagoras theorem is because the Pythagoras theorem says if I have an angle that's equal to 90 degrees, then the hypotenuse of the triangle squared plus the other two sides of the triangle squared are equal. But we're doing it the other way around. We're saying since the hypotenuse squared is equal to the sum of the other two sides squared, then that angle must be 90 degrees. So it's just the opposite direction of the Pythagoras theorem. 8.2, we're given this quadrilateral ABCD, where AD is parallel to BC. So these two are parallel. And we're told that angle B is equal to angle D. So these two are equal. Then to prove that ABCD is a parallelogram, I'm going to prove that both pairs of opposite sides are equal, so that AD is equal to BC and that AB is equal to DC. And I'm going to do that by the congruency of triangles. So I was already told that this angle is equal to this angle that was given in the question. Then since this line is parallel to this line, I know that by alternate angles, this angle is going to be equal to this angle, and this line AC is common. So then I can say that this triangle is congruent to this triangle, which means that the length of this side on that triangle is equal to the length of this side on this triangle, and this length is equal to this length. Then that means that the opposite sides of this shape ABCD are equal, or the pairs of opposite sides are equal, so these two are equal and these two are equal, which means that ABCD is a parallelogram. So I'm going to start with angle B being equal to angle D, and that was given. Then I can say angle A2 is equal to angle C1, and that's from alt angles, and it's from these parallel lines, the AD and the BC. And then AC is common, and that was given. Therefore, triangle ABC is congruent to triangle ADC, and that's from side angle angle. Therefore, AB is equal to CD, and AD is equal to BC, and that's from congruent triangles. Therefore, ABCD is palm, and that's because both pairs op sides equal. Question 9. ABCD is a parallelogram. That's ABCD, so these lines are parallel and equal, and these lines are parallel and equal. Then we're told that BH, which is this line, bisects this angle ABC. So B1 is going to be equal to B2 if it's bisected, and we're also told that HC bisects this angle BCD. So C1 is equal to C2. Then ABC, this angle is equal to 60 degrees. So if these two were equal and it was bisected, B1 is equal to 30 and B2 is equal to 30. And we're told that angle F, that one is 120 degrees. And we have that BH is parallel to GC, which is these two. And that BG is parallel to HC. And then we have that AD is produced to E such that AB is equal to DE is equal to 30, that's been labeled. And BC is produced to F. Okay, so question 1 asks us to prove that C1, which is this one, that C1 is equal to 60 degrees. So first I know that this line AB is parallel to this line DC because I was told that it's a parallelogram, and I was told that this angle B1 plus B2 is 60 degrees, which means that angle C must be 180 minus this one because of co-interior angles for these parallel lines. So I'm first going to say that those lines are parallel. And that's from Palm ABCD. Then I was given that this angle is 60 degrees, so I know that this angle is 180 minus 60, which is 120 because of co-interior angles. So this is angle BCD. Angle ABC. So 120 degrees is the size of this whole angle here, that's C1 and C2, but we were asked to just find the angle of C1, but we were told that this CH bisects this entire angle C1 and C2, which means that this angle is equal to this angle, so they're both going to be equal to half of this angle, which is half of 120. So I can say that angle C1 equals 60 degrees, and the reason is that HC bisects BCD. Okay, next I want to prove that BGCH is a rectangle, so that's this one, and I already have that these sides are parallel, so that's fine. So the other thing that I can show to prove that it's a rectangle is to prove that the opposite angles are 90 degrees. And I can do that because this line is parallel to this line, then this BC that's joining them. This angle B2 must be equal to this angle C4 because of alternate angles. And then similarly, since HC is parallel to BG and there's this line joining them, then this C1 must be equal to this B3 because of alternate angles again. So the B3 is going to be equal to C1, which we just found to be 60 degrees, and then this B2 is going to be equal to C4, and we know that B2 is 30 degrees, we were told in the question, and so C4 is 30 degrees. Then these two together is going to be 90, and these two together is going to be 90, and so the opposite sides, the opposite angles of the rectangle are 90 degrees, and the opposite angles of the quadrilateral is 90 degrees, and since these have parallel opposite sides, then that means that it's a rectangle. So I'm going to start by saying that B3 is equal to C2, which is 60 degrees, and that's because of the red parallel sides. And then I'm going to say that B2 is equal to C4 is equal to 30 degrees, and that's from the green parallel lines. Okay, and then I can say that B2 plus B3 is 90 degrees and C1 plus C4 is 90 degrees. Therefore, that quadrilateral BGCH is a rectangle. And the reason is that it was already a parallelogram with the two opposite sides being parallel, and now I've got a parallelogram that has the opposite angles equal 90 degrees, or all of the angles equal 90 degrees. Then we want to prove that DC is parallel to EF. So that's these two, the DC and EF. So we were told in the question that F is 120 degrees. And I know this angle for C1 is 60 and this one is also 60. And so by angles on a straight line, these two are already 60 and 60 is 120, and the angles on a straight line is 80. So I know that this has got to be 60. So if C3 is 60, then that means that C3 plus F is 120 degrees plus 60, which is 180 degrees, which means that these two angles are co-interior, and that means that this line must be parallel to this line. Okay, so I'm first going to say that angle C3 is 60 degrees. And the reason is angles on a straight line. Then C3 plus, let's say F is 120 first. And that was given. And therefore, DC parallel EF because of supplementary co-interior angles. Now we want to prove that DE is equal to DC. So we were told that ABCD is a parallelogram, which means that this side AB must be equal to this side DC. And we were told that DE is equal to AB. So if both of those things are true, then that means that DE must also be equal to DC. So I'll first say that these two are equal because of the parallelogram. Then these two are equal, we were given that. Therefore, these two must be equal. Then finally, we're asked to prove that DCFE is a rhombus. So we just found out that DE was equal to DC, we've just proved that. And we know that this line must be parallel to this line because these lines DE and CF are just extensions of this parallelogram ABCD. So these are parallel. We proved earlier that these were parallel, so I know that DECF is a parallelogram. Then I've proved that DC is equal to DE, so the adjacent sides are equal, and that's the further step that I need to prove that a parallelogram is a rhombus. So I'm going to say that DE is parallel to CF, and I'll just say that this is an extension of AD being parallel to BC. Then I proved that DC was parallel to EF. That's proven. Therefore, DCEF is palm. Upsides parallel. Okay, and then we just proved that DC is equal to DE. Therefore, DCEF is a rhombus. And the reason is adjacent sides equal.